Hello students, welcome back. Let's go back to section 2, limit rules. And we're going to start this example here. The trigonometric limit as theta goes to 0, sine of theta over theta is 1. Now, do you remember my reaction when I stumbled upon this problem in the previous video? After going through all the limit rules from 2.1 to 2.8, and then I opened this one, I went like, oh, whoa, we can't do this. This is an optional topic, let's move on. Well, alright, this is an optional video and we are back. And this is not for everybody, of course. If you're into mathematics, then this is going to be very, very important. If you're not, then you'll find this a bit too advanced. The main tool here is the sandwich rule here. So my function f of x is sandwiched by these two functions, g1 and g2, greater than or equal to g1, but less than or equal to g2, but both g1 and g2 converge to the same limit. Then f of x is squeezed by those two, and it must converge to the same limit as well. So how do I get my lower bound and upper bound? Let's begin with some geometry. Alright, let's begin with this picture. We have a triangle and a sector. Triangle ODA, that's a right triangle. And then we have a sector OAB. And then inside of that, another right triangle OAB. So here, in a big triangle OAD, angle A is a right triangle. Angle A is a right angle. And the smaller area, smaller triangle, OAB, angle B is the right angle. And then look at this picture and compare the area. Area of OAB is the smallest, and then the sector includes that, so sector's area is bigger, and the sector is included in bigger triangle, so that area is the biggest. You can clearly see that. And then let's express all these using the angle theta. Remember, the radius is 1 this time. So how do I get the area of the smaller triangle? Two sides and an angle in between. So 1/2, 1 times 1 times sine of theta. That's the area of a small triangle. Now, larger triangle, this height is 1 times tangent of theta. Tangent is opposite over adjacent. Adjacent is 1. So 1/2 tangent of theta. So 1/2 theta is captured by 1/2 sine of theta and 1/2 tangent of theta. If you're not directly getting this area formula, then you can deduce those from standard triangle area formula. 1/2 base times height. Base is OA and height is BE. And what is BE? If you look at this even smaller triangle, angle E is a right angle and 1 is hypotenuse. So this height BE, that's the opposite of theta. So that's hypotenuse OB times sine of theta, as I highlighted in red. And OA, OB, those are all 1. So 1/2 times 1 times 1 sine of theta, that's the smallest triangle. Larger triangle, 1/2 OA times AD, but AD is adjacent times tangent of theta. OA, AO, they're all 1, so 1/2, 1 times 1, tangent of theta. There's a deduction of those. Anyway, that's the conclusion. 1/2 sine of theta, 1/2 theta, and then 1/2 tangent of theta. Now assume theta is greater than 0, and then dividing all by 1/2 sine of theta, we are dividing by something positive, so the direction of that inequality doesn't change. So divide away theta over sine of theta. Let me expand the fonts so that you can read better with all those fractions. And a tangent over sine, 1/2 is all gone. And tangent is sine over cosine, so you can rewrite this as 1 over cosine of theta. Remember, assuming theta is greater than 0. Now, when theta is less than 0, we have to do this all over again, but that's something we can discuss after everything is done. All right, flipping everything, we're going to get the opposite. We'll have to flip the direction of all those inequalities. Again, we can do this because everything is positive. So cosine of theta, sine of theta over theta, and 1. And then we're going to apply the sandwich rule. Take theta to 0 plus. Remember, theta is positive. We are assuming theta is greater than 0 to do all those, so we are doing theta plus only. We get the sandwich rule. Limit theta is going to 0 plus cosine of theta, and then limit theta is going to 0 plus just 1. Now, this is constant, so stay at 1, no problem there. And this one, that's also 1 because cosine of theta is 1, you see? Cosine of 0 is 1. That's a trivial limit. Just plug it in. So left-hand side is 1, right-hand side is always 1. And that's squeezed by those two, we get the conclusion. Limit sine of theta over theta is 1 as theta is approaching to 0 plus. Remember, assuming theta is greater than 0, we are doing all those computations. Now, we can compute the left-hand side limit as theta going to 0 minus in a similar fashion. Hence, we get this. And I didn't give you any of this actually. Well, if I give you a little bit of hint, in this picture, theta is positive. As you can see, the angle measurement is counterclockwise non-trivially, so theta is positive. Now, if you want theta negative, then you have to establish something similar, backward, clockwise. In other words, we're going to end up with this kind of picture. Like this. So that this angle theta is negative. Similar picture, same picture as a matter of fact, but flipped downward. And then do exactly the same thing. Yes, you may have to be a little bit more careful about doing dividing by negative sign or things like those, but those are minor issues. Basically, you can set up the geometry same way and apply the same logic. Just do careful computation and everything follows. And the detail is left to the students. A bit trickier, of course, yes, but the key idea is identical. So nobody actually cares about this negative size, to tell the truth. And another way is to substitute theta by negative theta and then doing the change of variable as well. So the conclusion, well, we have it. Limit as theta is going to 0, sine of theta over theta is 1. Is there any application for that? Well, here's another. Limit theta is going to 0, cosine of theta minus 1 over theta is 0. So how do I use this to prove that? Well, we multiply by conjugate here. Cosine squared plus sine squared is 1, so sine squared is 1 minus cosine squared. And then we have cosine of theta minus 1 here, so if you multiply cosine of theta plus 1 to both numerator and denominator and do a simplification, you get, well, this computation, which involves cosine squared minus 1, so negative sine squared. And that's how you get sine of theta over theta separated out. And this limit goes to 1, and the second limit goes to 0. Sine of theta over 0 plus 1, or over 1 plus 1, excuse me. Cosine of theta is going to 1. So that's a trivial limit here. So times 0, you're going to get 0. Okay, all right. We went through this trigonometric limit, and we will use this limit of sine of theta over theta as theta goes to 0 is 1 in various places when you do the limit computation with trigonometric functions. So please remember this formula, but as for the proof, if you remember, great. If you don't, then never mind, you can just skip that. If you are majoring in mathematics, then yes, you have to study that one way or the other. Okay, that completes this optional topic. Let's stop here.